Have you ever asked or been asked why your inline pH measurement doesn't match your reference measurement? When I'm talking about reference measurement, that could be a redundant inline measurement, it could be a portable measurement, and more often than not, where people run into trouble is when they're comparing to a laboratory measurement that's done offline and usually at a different time. The objective of this video is to help you to troubleshoot why those measurements don't match so that you can have more confidence in your inline pH measurement. So in order to do that, I've already made a little chart here. We're going to go through the top 5 reasons why those two measurements, your inline and your reference measurement, don't match. The first and most common reason usually has to do with calibration and maintenance. Okay, when I'm talking about calibration, it's really the frequency and the quality of the calibration. So let's start with quality. Your measurement itself is only as good as the calibration that was done on the sensor. So make sure you have very clear and concise calibration procedures, that you use fresh buffers, and if you're using M4 Knick product, we recommend that you use your Power of MemoSense offline. With regard to frequency, it really depends on the application and more so on what type of wear or buildup are you getting on the sensor. If the sensor is not clean frequently, if you're seeing fouling, things of that nature, that could affect the accuracy of your inline measurement versus your reference measurement. Next, I would say in importance is installation. How is your inline measurement installed? And we're talking about a couple of things. One, its actual physical location. So where is the sensor installed with regard to things like when you're doing a neutralization style application? Are you mounted near the dosing pump so that every time that acid or that caustic is pumped into the line, you're getting hit with that high concentration? That could cause the inline reading to be off from your laboratory or redundant reading. The other thing is also related to digital versus analog. If you've got an analog installation, it's possible that electrical noise or grounding issues could be causing that inline inaccuracy versus what you're seeing from the lab. So think about installation, number 2. Number 3 is temperature. So we all know the Nernst equation, right? Temperature has a direct impact on the accuracy of a pH reading. The higher the temperature goes, typically the lower the pH goes. So if you're using an offline type of measurement, either a portable or a laboratory measurement, it is possible that that temperature differential that you're seeing from the inline measurement could cause you to be off when you're comparing the two. So just keep that in mind. Temperature is very important. If you want to get as accurate a measurement of what's happening in line, you want to take a sample nearby the installation, as close as possible to where that sensor is installed, and take that portable measurement as quickly as possible. That's the way that you can avoid that type of discrepancy. Number 4 is flow. So obviously, if you're using a laboratory measurement or a portable measurement, you're not going to be in the flow of the stream. So typically, we look at flow speed when we're talking about impact on accuracy with regard to pH measurement. We're targeting a flow speed of between 5 and 6 feet per second. If you get slower, it doesn't typically affect accuracy as much. Slower than that typically allows for buildup. It's when you get faster than 5 to 6 feet per second, it can actually affect the electrical potential of the sensor, thereby causing what appears to be inaccurate and sometimes drifting readings. So be aware of the flow. Last but not least is technology. Oftentimes, people are using 2 different types of sensors and comparing the readings from them. Although you would think, yes, if they're both calibrated properly, you should get the same reading. There's different, not all pH sensors are made the same. The glass recipes by manufacturer are different. The electrolyte recipes can be different, and even the sensor construction can be different. If you're trying to really help your people in the field, the operators running your process, you really should use the same type of technology as much as possible. And that's really where, for M4 Connect customers, the Portavo comes into play. We can eliminate a lot of these issues. We have MemoSense both in the field and with the portable. We can take the measurement right next to where the inline measurement is made, the sample, and it's portable, it's easy, you can take it in an electrically classified area. So we really recommend, even if you still are going to use those offline measurements, to use a Portavo as another way to validate which one of those sensors is accurate. So hopefully this quick video will allow you to troubleshoot some potential influences on your inline measurement that your redundant or reference measurements aren't able to see. Thank you very much.